This is Chuck Lamson. In this video, I just want to share with you the build log from this. This is a foam wing for RC flying, and this I built up from core that I had laying around. When I say core, I mean I just had a wire cut set of wings that were made of EPP foam. I got these from Lee Aston, who owns a business called Crash Test Hobbies. And you can find that website online. It has a lot of information on it. He and I flew together for years. I haven't done much flying for about 7 years, so I decided just to get back into it a little bit by building this. So I'll show you everything that was done to build it. So the things I've done so far is, number one, reinforce the wing. Again, you go to the Crash Test Hobby site, you're going to see a lot of information about this, but the first step is always to cut in a razor cut around the whole edge, the whole perimeter of the wing, and insert a string. I just use nylon construction string, and then I glued it in. And what that does is it's a very lightweight method for toughening up the wing, because a lot of times the main impact is straight into the ground, straight into a tree, straight into a wall, which is going to put a lot of forces on this wing when you've got all the elevons and everything in it. And a very common problem is you form a tear right in here. But with the string in there, that tends to not allow this foam to separate and tear. It tends to distribute the stresses along a larger area of the surface and prevent those tears. So that's the first thing I did. Again, you can see the details of that on Crash Test Hobby site. In addition to that, I put just one stripe of 3M fiberglass tape along both front surfaces. This is the double weave tape that Lee uses in his construction videos. I just had some left over from years ago. So I put it on the leading edge. What that does is help to prevent tearing or breaks whenever you hit something sharp going straight forward. Just toughens up the plane a little bit. You'll see that in a combat plane you put a lot more tape on it than that, but this is not for combat, it's just for fun. So I want to keep it very light. For elevons, normally if I got a kit, I would have the elevons in the kit and they would be made of foam. In this case, I went back to the old method that we used for a long time, which was making my own elevons out of balsa. And I made these fairly small. This is only 1 1/4 inch deep and 1/8 inch thick. I went ahead and sanded 45-degree angles on the elevons so that when I tape them on, I can, use the elevons without conflicting with the back of the wing. I've got some wingtips. These wingtips will be glued onto the ends of the wings to kind of stabilize the yaw. It's a pretty common thing with these wings to put wingtips on. It's not totally necessary, but you might get a little wobble if you don't have them on there. These are just the tips of an old striker that I built a long time ago. I don't know if you know, some of you may know what the striker is. I would usually cut the top off of those striker fins because they're so tall, and I just decided to use the tip of that for these wingtips. It's very light. It should hold up pretty well. I'll glue it on there with goop. See how it holds onto there. If it doesn't work too well, I'll go ahead and tape it on as well. Motor mount. So again, to make a very lightweight motor mount, what you can do is what I've done here. It might be a little hard to see, but I've taken just some foam from an old build that I did, basically a crashed plane, and I cut it into this little mount shape. I cut a little V out to square off the back of this wing to place in there, and I glued that all together with Gorilla Glue, the foaming kind of Gorilla Glue that sticks really well. So that forms the mount, and then what I'll do is, this is a piece of Formica. So I'll drill holes when I get my motor. The motor and electronics are still in the mail. When I get the motor, I'll place the drill holes, probably 4 of them for the motor mount, and I'll go ahead and bolt the motor to this piece of Formica. And then I'll use a soldering iron to make indentations in the back here, wherever those bolts are going through the Formica, just to allow me to seat it directly onto the foam. And then using hot glue, I'll apply hot glue first to the foam so it doesn't, because if I put it on the Formica, it might cool off too fast and harden. I'll put it on the foam, and then with the motor mounted to this Formica, I'll go ahead and cement it onto there. And that should hold up really well. I've made these motor mounts before. This Formica adheres very, very well to the hot glue, and a small motor should work out really well. What else? Oh, I forgot about one thing. I also put in a spar. This is just a 3 millimeter. I don't know if you can see that. Yeah, you can see a little bit of darkness there. That is a 3 millimeter carbon fiber tube that I had laying around that I went ahead and cemented in there, made a trench with a knife and some pliers, pulled the foam out and put in that spar using, again, the foaming Gorilla Glue. So basically, I think for now, that's it. So this is where we are. We left off with this core all built and ready for parts. When I receive the parts, then I find places for them all. And go ahead and cut those places right into the foam so that everything is kind of mounted flush with the service. You can see these servos are cut in here. They fit tightly in there. I will actually put a little bit of hot glue to make sure they stay before I put the covering over them. Most everything you see here will be covered once I put the covering on. So what I'll do is remove all these components, mask off the places that I'm going to use glue. Hot glue will be applied here, and some goop will be applied on these ends here, so I'll mask those off. And I'll spray this whole thing with spray adhesive so that it accepts the covering well. Let me just point out things one by one. Here's the little 6 amp speed controller right here. Not very big. I'm used to 30 amp speed controllers, which are about, I don't know, 7 or 8 times bigger than that. That, of course, has a lead going to the battery. In this case, I'm putting 2 batteries in the front. So I've made a Y connector here, a parallel Y connector, so that I can hook the 2 batteries in. All that's carved in below the surface of the foam so that when the coverings goes over it, all that will be flush with the surface, except right here. It'll come out of the covering here, and these are the 3 leads that go back to the motor. And you can see I've now mounted the motor to the Formica. Now, just one point about this is whenever I mount something like this, a motor, there's a little bit of vibration. So I put a little bit of Loctite on the threads so that they never come undone. And I've already prepared the back side there so that it'll be flush. I just take a soldering iron right out. You can see, oh yeah, you can see them. Those little holes there were melted in with a soldering iron. They just make space for those bolts. Okay, so that'll come last after all the coverings are done. What else? This is just a servo extender because this servo had a long way to go to reach the receiver, which is right here. Again, embedded flush with the plane. So when the covering's on it, none of that will stick up above the covering or even make a lump in the covering. I'll have to tuck this in. It's got a little bit of extra servo wire. And the same thing here. That one's fit in tightly, and I'll just hot glue it a little bit so that I could get it out again if I need to. Now, one thing to note, these two are both Metal Gear servos. You can see the MG there. Long experience flying these flying wings. The elevon has more mass than a regular aileron does. And so when these things crash, that's a lot of force, and it will strip a regular servo. But these Metal Gear servos hold up pretty well. The last thing, I guess, is the batteries. So the batteries you want to put towards the very front. This I've just chosen to use 2 batteries. They're little 2S, maybe 500 milliamp hour batteries. Let me look here. Yeah, 500 milliamp hours, 2 of them. I use these for other planes too. That's why I put 2 of them. I didn't want to get a big battery in there because I don't have any other planes to use it in. I like to stick with just one size of battery. But you see, I cut the slots all the way through. Those batteries are about the same height as the wing. I will actually put some tape on the underside so they don't have those holes. I'll put a little hole in the center of the tape so that I still have a way to push up with my finger and get the battery out the top easily without having to fiddle with the foam too much. So I thought I'd close by just talking about a few characteristics of the plane. The only places where electronics protrude is right here where you plug in the batteries. And once those batteries are plugged in, it's pretty low profile. Do that quickly here. The only place you really have resistance is right there where the wires stick up and here where the motor mount is. The rest of the wing is all mostly just wing surface area, nice and clean. The batteries pop right out. I put my finger right there and push on it. I can pull the batteries out of the plane easily, put them back in. I did wind up putting a little bit of weight in the front of the plane. It took about 1/2 ounce. Flight characteristics are very good. Once it was balanced out, it glides super well because it's quite light, and it's quite aerobatic too. It's just a 2S setup with a 5-amp motor, but it's pretty zippy. It easily loops, rolls, flies inverted, climbs pretty well. It doesn't have unlimited vertical or anything like that, but it goes along pretty good. Also, I can slow it way down and just cruise around near the ground, and it's quite stable. Stalling, no problem at all. Once it was balanced out, I really can't really get it to stall. If I drive it up at a steep angle and shut off the power, then it will stall, but it just quickly dips and recovers. So very nice flight characteristics, easy to handle in the air. I always make one wing have at least the bottom side of it have a nice bright color on it so that I can easily see the direction of the plane, whether it's coming towards me or going away. I usually make the tail of the plane a little bit different color so I can easily kind of tell the orientation of the plane in the air and keep locked on to the controls. And this color scheme has worked really well. Maybe the last thing I'll do is just power it up. I don't have anybody to go to the field and take pictures of me flying the plane, so I'll just kind of do a little static demonstration here to show you how things work. Turn on the radio, the transmitter, and I'll just, oops, my switches need to be all turned up. There we go. It's the correct model. I'll just plug in one of these batteries, which should turn on the speed controller. Oh, there we go. And orient the plane this way, away from me. Now, you see if I pull back on the stick, the elevons both go up. If I pull to the left, the plane will bank left. I pull to the right, the plane will bank right. Let's check and see the thrust, make sure it will move along in the air. So there the motor is on. It has plenty of thrust with just this 2S setup with a 5-amp motor. So again, I'm very happy with it. And that's all for this video. So good luck to you on your next build.